Hello. So in this first video on VecML, I want to introduce you to a bunch of our products. So the basic technology is inside the dashed lines, our software. So imagine you're a business and you have a whole bunch of products, say 100 million products, whatever. And we can encode each of those products as a vector and we embed them in a large language model somehow. And then we offer a search engine and machine learning functionality, as well as some privacy. And then people can run various queries, or we can do various kinds of machine learning inference, and to output results like, say, recommendations or sentiment. These things are good, those things are bad, or lots of useful cases. And so many of these real business needs can be expressed in terms of things that we offer inside the dashed lines. Now we're going to talk about a functionality which we'll call a neuro search engine. This is sort of an extension of concepts like learning to rank, which is a traditional way of thinking about web search. And the basic idea is that you have a query or a prompt, and you embed that as a vector, and then you have a bunch of documents or products in your database, in your vector database, and we'll represent that as doc_i. And then you can represent the similarity with standard metrics like cosine or Euclidean distance, or we're going to have a more general thing, which we'll call a neural match. And then from this kind of thing, you can say, given a query and a database, go find me the top K, the top 1, the top 10, the top 100, whatever, matching objects in the database. And so the initial products that we are demoing now, we're talking about in the next video, be three types of products. One we'll call prompt generator. That is, you upload a couple of documents, say PDFs or standard documents, and then we can turn those queries into prompts to a chatbot and answer the questions about those documents or about anything else. The second set would be, we call the machine learning platform, and we'll show a simple case of classification. Regression would be another simple thing you could do. There are lots of things you could do if what you have is vectors with some kind of labels like class labels or scores we could use for regression. And the third set would be the neural search engine. We talked a little bit about that on the previous slide, where you have a database of vectors, and then you have a query, and we can do a top K search. We have some ways of adding privacy guarantees or business filters, like maybe you only want things with certain labels or within certain time constraints, space constraints. Maybe you only want a job that's in a certain region of the world. We offer functionality to work with either dense or sparse vectors, and we can work with a GPU or CPU or whatever, and we can integrate all this within machine learning, so you don't have to. You can mix and match what you have with what we have. So in the next slide, we'll show a couple of examples of some of these features in our web-based interface, and then we'll show in the video after that how to do a few different things in the Python implementation. The web thing is very easy to use. The Python is probably easier to interface with other functions that you may have outside of our products. Thank you. Hello. So in the previous video, we talked about VecML's products, and there basically are three categories. We have the prompt generator, we have machine learning, and we have search. In this video, we're going to talk about the web demo of the first two, of two simple examples of the first two cases. Right. So we're going to talk about the prompt generator and classification. In both cases, we need to upload some documents. In the first case, we can ask questions about those documents. In the second case, we can train a classifier and we can use that trained classifier to make predictions on held out cases. So here's some documents we're going to upload in these QR codes here. You can get to these documents if you want. One document is earnings report from NVIDIA, and we can ask questions about how well it's doing. And then the second document is the PhD thesis by the CEO of VecML. So let's go to the demo. And here we are at the demo. Let me make it a little bigger. Oops, here, bigger. And if you'll need an account, you can get one there, or you can go here. And here it says there's a sign up if you didn't have an account. I have an account. I'm just going to click on that and sign in. It takes a little while. Let me delete these cases. I shouldn't have had that there, but I did. So we just say delete that. Yeah, delete. And then I'm going to delete this. Delete set validation. Now, what we want to do is to start with the documents for chatbot. And I'm going to upload a couple documents here. Not those. Yeah, these would be good. Let me take the NVIDIA and the thesis. Here they are. So you can see I'm about to upload the earnings report and the thesis, and we'll call this private docs. And it takes a little bit of time, but now I can start asking questions about that. Maybe I need to make this a little smaller. Okay. So let me say, what are the earnings for NVIDIA? And it gets the right answer right out of that report. Isn't that wonderful? Let me try something a little silly, but will NVIDIA be worth more than Apple? So that was ask a silly question, get a silly answer. What can you say? All right, now let's start asking about some questions about Ping's thesis. So, who was Ping PhD advisor? And that's the right answer. And um, who did Ping Lee? Okay. What papers did Ken Church and Trevor Hasty? Okay. Yeah. Okay. And so this is a topic in his thesis, and it's somewhat related to the VecML products. Anyway, it goes on for a while. So that's pretty much what we wanted to ask about that. Let's switch topics, and I want to talk about, let's go back to this PowerPoint, and let's talk about classification. So in this case, we're going to upload a train file and a validation file. And for these two files, we're going to get them from a standard repository. You could get all kinds of vectors from all sorts of places. These days, for example, if you have any text or any images or any speech, you can use standard models from Hugging Face or something like that to generate these vectors. And then suppose you have some labels that say these are good and those are bad or whatever. That's how you get the output labels. So what we're going to assume is that the inputs that we have are going to be X's, which would be vectors, and you can get that out of a BERT-like model or whatever. And then the output labels would be some kind of categorical variables. And we're going to upload some of these well-known examples from this repository. And so let's do that. So let's say I'm going to go here and let me make it the set. And I need to upload a file. And let's get some files. So I'm going to upload that file. And let's go back here. And I want to upload another one. Let's call this set validation. And I want to upload a file for that. So let's go to here. And I'll upload that. And I come back here and let's go back here. And I'm going to train that for classification. And then I want to go, let's say predict. And I want to predict on the validation set. And look at that. That's incredibly fast and it's quite good accuracy. So that's what we have to say about that. Now let's go back here. And so that finishes the web demos of the two cases. The web thing supports more than that, but this I think gives a quick example of the kinds of things that you can do. In the next demo, we're going to show how to do very similar things using the Python implementation instead of the web. The Python makes it so you could do things more programmatically. So if you want to connect this directly. Okay, so now we're going to show how to do many of these functions using the Python interface. So we'll start with the installation. And pretty much all you do is a pip install. We're going to also make use of a couple of other pretty standard Python packages. So for classification, this is what we're going to do. Now, the API key, I don't want to share it with you, but I'll show you how to get to it. So let's go to the demo. And I need let's see. Let's go to VecML. And again, here, if you need to log in, I'll log in with that. And ignore all this. It doesn't, these are just things I've uploaded before, but the API key is here, and that's my secret. You generally shouldn't share it, but I'm going to destroy this one anyway. So, um, you know, anyway, that's how you get your API key. Also, if you look in the Python documentation, your API key is this thing, right? So let's go back to the installation. Um, and oh, we already did that classification. Let's do that. So I want to go here and let's grab this, get into a shell window, and I think I can just say that. And this is how I run it. Now, VecML underscore classify dot py is a function I wrote. So I'll show you what that looks like. But the main thing I want you to see here is that we uploaded these examples and we did a whole bunch of classifications and they ran pretty quickly. And here are some of the output probabilities. Um, and it's well, you can see here the accuracy is quite good. So what does the code look like? So let's go back to the PowerPoint and oh, I seem to have here's the code for it. And you can see that it all fits on one screen. It was just 33 lines. Much of it is just passing arguments. So it takes a train file and a validation file. You need your API key, and I put that in an environment variable. Um, and then there's a use of these two VecML functions to upload the data. Um, then here we loaded the data using some standard SVM light functionality. Uh, this initializes the interface with my API key. We upload the train file, we upload the validation file, and then we do all the work here uh, with the train function. And that's then we just print out the results. That's it. It's pretty straightforward. So here's the query search functionality. Um, and it's going to be very similar. So let's go back to the demo. Um, let's say clear. And then I want to go here and get the query. And while that's running, let's go back to the PowerPoint. Um, Here I want to give the overview of all the functions that I'm using. So vecml.init, that uploads your key. There's a bunch of different functions for uploading data, depending on whether it's sparse or dense. Um, and then we've got a train function predict. This is going to be used to make the queries run fast, and then query is to actually do the query. So we can go look at um, what we had done for the search, um, and uh, the search functionality is a little longer. It fits on two screens. The first 24 lines is just doing argument passing. There's a function I didn't explain here, the filter. So you have a train and a test file API key. That's pretty straightforward. Top end is, do you want one answer? Do you want 100? Whatever. And then filter is that you can have hard constraints. And sometimes this is useful if you only want to look for a job, say, in one part of the country, you're not interested in jobs elsewhere. Um, and then we have some helper functions here that will load the data off of my disk and then upload it into our VecML API. The next, this is where the work is done. So we pass our API key up to VecML, and then we load the data and we index it. Um, and then here, if there's no filter, you call it this way. And if there is a filter, you call it that way. And then you just print out the results. And that's it. It's pretty straightforward. Um, so let's see how well it's done. It was quicker than I was there in discussing all that. And this basically outputs uh, the uh, um, the 100 best answers to each of those queries. So let's go now to the final thing, which is, oh, I'd like to talk about that. So for privacy, um, the what you do is when you call in this example, we're going to show it's an MNIST example. You can have it with and without privacy. If you want privacy, you just add this extra argument. Um, this is just a placeholder where we're going to put our database, and we have two versions of this: one that's private and one that isn't. And the privacy preserving capability would be a little bit slower than the other case, and maybe a little bit less accurate. But it's privacy preserving, which is kind of nice. So let me show a demo of that. And I want to do a Python test MNIST. So that's going to, while it's running, let's go back to our um, slides. And oops. So we have, this is the test MNIST code. There's quite a bit of code here. I redacted this API key. That should be a secret. Keep your API key secret. I shared with you one for a dummy account. I don't care about that one, but I think this is actually a real account. And then this has got some code that MNIST is a standard task, and we've got it all. We're loading it here. Um, and now here I called it without the privacy argument. Um, and then we're done with the insertion. Now the bulk of the work is on the second slide, where we're going to test it with a top K ranging from 1 to 100, and the 1 will be faster than the 100 and so on. It's going to print out the top K, which whatever value that was. And then it's going to do the queries over all that. And this is a fairly large collection, and it'll print out some summary statistics of how we did. So here it is. It did the top one, it did the top 10. We're now working on the top 100, and we're halfway through that. The query time for the top one, my machine's a little bit slower than other machines. This is just my MacBook, a laptop, and it's a bit old. So that took 15 seconds to do the first one, 18 seconds to do a top 10, and top 100 is a bit slower. And that's that. Now let's try the same thing with privacy. And this will be a bit slower, so I have time to go back to my PowerPoint and just make sure that we're understand what's going on here. Um, so the only real difference with the privacy is that we added this extra keyword to the insert, and then everything is private. Um, and this is if you care about your data, you might actually do this so that you don't have to worry about. A lot of people would be concerned about uploading private data to a public cloud, and so this gives you some privacy preserving functionality. So we'd recommend that for stuff you care about. And this is a differentiator. I don't think so many other. This is something that we uniquely offer. Let's see how we're doing. So we're just uploading the data. This is going to take a while. So let me go back to the PowerPoint. Um, and so just to summarize what we were talking about in the Python implementation, we discussed how to install the package. We showed a very simple case of classification, very simple case of searching, and then the MNIST is a larger problem, and we showed that doing the top 100 is maybe twice the time to do 1 or 10, and then we can show what it's going to be like with and without privacy. So let's go back and see how we're doing. Okay, so we're now on the top 100. So we've made some and it's 68% done. So we don't have to talk too much longer. So you can see here the query time was 36 seconds, whereas before with without the privacy, it was 31 seconds. So it's a bit slower. And you can see that the accuracy is very close to where it was. So it's almost as good and a little bit slower. All right. So that's pretty much what we wanted to say. Thank you.